So having said, having looked into fault domains and upgrade domains, and our upgrade is very important concept when we think about deployment and upgrading our applications. Let's move on to specific topic with respect to role programming models. So we have multiple events, multiple methods and events available in our web role and worker role. So to begin with, we have an onStart method, which is always called by the Fabric, Windows Azure Fabric, to start our web role or worker role for that matter. It does all the initialization tasks here, and it reports the status to the load balancer where it is like ready or not. Once it is ready, it actually adds into the load balancer, and that web role or worker role is available for usage. A run method, this is very important in terms of its main logic for mostly worker roles, but you can make use of this logic in your web role also. It is always running, and you can do all the infinite loops or any specific task which you want to run all the time. You can do you can write that code in the run method of your role entry point, that is web role or worker role. You should never exit out of this. The moment you exit, it is actually going to recycle your role. OnStop method, it is called when the role is going to be shut down, and it is actually graceful exit. I mean, it is not going to get shut down immediately. It gives some around 30 seconds where we can do some specific on-stop activities when your role is going to stop. Let us look at the role life cycle here. So we saw the deployment life cycle. Now let's see about what happens when we start a role. So all roles extend from role entry point. There is a class which is being used by Windows Azure. We are going to see that in the code again. Roles report status via role environment. There is another static class which we have, and it is being reported back to the Azure Fabric controller, and depending on that status, Azure Fabric controller takes appropriate actions. For example, if your role is busy for too long, if it is down, it will start spinning up a new virtual machine for your roles. Let us see how it works. So you have the Fabric calls a method called as onStart, just to try to initialize your roles and make sure that it runs. It keeps checking the status. There is an event for us, status check, and when the status, generally when it starts starting up, the status is busy. So the moment you get status as ready, your run method is called from the Fabric calls, so that whatever infinite loop you have, it's keep running all the time, and your actual requests are routed back to your service from the endpoint. When the onStop, when by any chance if you are stopping your service or if there is a problem in virtual machine, it is actually going to call this onStop method, and the status when it is calling this onStop, the status will actually go back to busy, so that it is not available for the external users to make use of that virtual machine. So that is the basic role environment cycle which we have: onStart, run, and onStop. These are the methods provided by role entry point class, which is being used for all the roles available in our Windows Azure. We have another event called as stopping, and which occurs before actually stopping, before calling the onStop method altogether, and that is where we can write code to handle and graceful exit of our virtual machine. Apart from looking at those methods, there are a few events which I want to specifically talk about, and just to make it short, I kept some code blocks here. Now, one event, stopping, where how do you assign that event is like using role environment dot stopping. That is an event exposed by the role environment, and you can capture that event using this stopping event. And whatever you want to do in graceful exit of your role instance stopped, you can write that code in here in this event. Status check, another interesting point, like another event which Windows Azure Fabric controller or role entry point is giving us is status check. We can add a hook to it and trap that status check event. A very specific example I just want to throw out here is, in some cases, if you want that your virtual machine should be running, but it should not be available outside in your load balancer. In those cases, you can explicitly set the busy status to true. Using that status check event arguments E to set busy, so that it is not available to the load balancer for some time, and the request will not come to your web or worker role for that matter. In some of the cases, you might want to do that when you are developing complex applications, and this is the place to use that status check. When we change configuration values in Windows Azure, we saw that whenever we change that, our web roles, our worker roles, our virtual machines are never down. The change which I make, it is actually slowly, gracefully passed on to our virtual machines. How does it do that? I mean, if I want to do specific task in, well, when somebody is changing the configuration, these are the events which are available to us. So role environment dot changing, it occurs before configuration is changed. So for example, if I have a connection string, data connection string, which is pointing to my Windows Azure storage, I want to change it. So the moment you change it, the Fabric controller is going to call this event on your role environment called as role environment dot changing, and that's where you can take care of if you want to restart that virtual machine, or you are okay with not restarting and just using the new setting in your application. And if you want to recycle that, you can actually set that to cancel equals to true, and it will restart that virtual machine and take the next settings once it restarts. Changed event occurs after everything, like all the config changes has been applied to all the virtual machines. So there is a parameter which we can make use of, role environment configuration setting change. That is where we get all the values what has changed in that configuration value. So there are two things. One is a configuration setting change and one is a topology change. So configuration settings means your application settings related values which you change, and topology change would mean mostly the role counts. Like for example, as of now I have 2 instances running, and if I make 4 instances or from 2 to 1, so it is actually going to change my topology of my application, and that is where we can make use of these collections, role environment topology change. We'll see the example how do you do that in our code. So we have this changing and changed event code again. So I just wanted to put it here so that we understand what it does. If you see in this example here, so I'm in on start, I am just adding a hook to the changing event, and then I get this event here. And here I can, using this changing event arguments, I can change what has changed. So I'm saying if anything changes, and if that change is configuration setting change, I want to restart my virtual machine, because everywhere in my code I have cached that configuration setting, and that is why I want to restart it. If you don't put it e.cancel equals to true, it will not restart the VM, and it will just slowly go to the changed event, and it will apply all the change settings to it. Now another point, local storage, which we introduced initially. So this is specifically, as we said, role instances has their own virtual machine. So virtual machine should have some disk storage available to us, right? And that is where the local storage is. So every role instances has its available disk storage. We can use local storage element in the service definition file to mention that we need this local storage, and we can actually mention that what is the name of that local storage and what is the size of it. There are 3 attributes to it. Name, how you want to access that local storage, and if you want to clean on role recycle. It is possible that when you are actually recycling your own role, it is highly possible you're going to get the same virtual machine because we have recycled that intentionally. So do you want to keep those values or those files which you have created on local storage? And that is the parameter which you can mention here, clean on role recycle. If you say true, it is going to clean it. If false, it is not. It is going to keep the files there itself. And you can also mention the size of how big that local storage should be. You can create multiple local storage for that. We'll see that in the demo, how do we create local storage and how do we access it. It is persistent, but it is not guaranteed to be durable. Yeah, because it is part of that virtual machine, and if I'm recycling or if my virtual machine is going down, I might get a new instance altogether. So all the files, all the values which I have stored in my local storage might get lost because I'm going to get completely new VM. And that is why it is good for cached resources or temporary files which are not very durable, which we don't want to be durable. For durable storage, for durable files, we have options like, you can make use of blobs, and you can also make use of storage drive, that is Windows Azure Drive, which is as good as your local storage like D:/X:, whatever you want to access it through. You mount it as a drive, and that is durable, accessible across multiple VMs. So even if your VM is down, you're actually whatever you wrote on that local storage or that drive is stored in the blob. So it is highly available, it is durable across virtual machines. That is local storage. How do you define that in your service definition file? So there is a config setting for local resources, and you can just say local storage name of my local resource, size in MB, and clean on recycle. How do you use that in the code? role environment.getLocalResource, give the name of your local storage name which you have given and the root path. It is going to give me the root path where it is going to create. So it is abstracted from us. And then you can just go through the directory info and you can just do normal system.io operations which we have been doing on our directories. We'll see an example once we run the demo for Windows Azure. With respect to configuration values, so there are two ways. One is you define your configuration values in service definition, and then you have those names of the configuration values, configuration settings in your service definition file, and then you put values in your configuration file. Don't use web.config for values which you wish to change, at runtime. So that is the beauty of service configuration file. So what happens is web.config file is part of your package and you don't have access to it once it is deployed. You might want to change a value in web.config on a package and redeploy it. But in service configuration, it is available there. You can just make change on it and it is not going to redeploy the application. That is where we saw this role environment events, right? Changed event, where service configuration might change and it can actually just respond and be there as it is without actually taking down that VM. So the tip is you want to use service configuration for the values which you wish to change at the runtime and not the web.config. Now startup tasks. What are the startup tasks? So they are actually introduced in